Welcome everyone to this video where I will be talking about CLDs or causal loop diagrams associated with systems thinking. The material for this video is from a report by an author called Hordar Haraldson, which is called Introduction to System Thinking and Causal Loop Diagrams, published in 2004 by Lund University. So this video is about how you can draw a causal loop diagram. It's a very kind of simple explanation, if you like, an introductory explanation that I hope you would gain a lot of, as a starter if you don't know how to do that. So let's start with that. Let's start with what is the purpose of a causal loop diagram. So the function of causal loop diagrams is to map out a system structure and feedback to understand how its behavior develops so we can create strategies that work with or counteract this behavior, the system behavior. Also, it can be useful to understand to what degree and how a problem can be linked with other systems as well. So this is the purpose of causal loop diagrams. So it all starts with a problem. You need to define a problem. And I talked a bit about that in the previous video that you can watch on YouTube with the material by the same author and the same report. So it all starts with a problem. You have a problem and you need to define it. So Haraldson says every time we are looking at an issue or a problem, we start asking questions. Every time we want to understand a process, we ask questions. We form questions as why this or that is happening in the problem, and how can it be solved or understood. And this is on page 20 of the report. So the causal loop diagrams always reflect our questions. This is what Haraldson says. Therefore, we can't confine the system to the question asked, and therefore the question becomes the system boundary around that problem. So then we move on to what do causal loop diagrams describe? So causal loop diagrams, and Haraldson explains that they describe reality. That is a reality of a situation that we're trying to examine. So they describe reality using cause and effect between variables or factors and how these form dynamic circular influence. What we are after is the feedbacks, not linear relationships between these variables or these factors. And also we want to see repeated patterns so we can predict the behavior in the problem that we are examining. Okay, so this is what CLDs or causal loop diagrams describe. Now, let's move on to something that is important, which is on page 23. And which is about the basics of CLDs, the basics of causal loop diagrams, and how you start drawing these on a piece of paper, if you like, or even how do you start thinking about them, and what is important when it comes to causal loop diagrams in system thinking. So to use systems thinking, we need to follow several rules so that we can illustrate the cause and effect in the right way of a problem. Okay, so what we start with, and Haraldson give 5 main components that you need to keep in mind, 5 basic things when it comes to causal loop diagrams that you need to keep in mind whenever you want to start drawing them. So the first one is there is an arrow. And this arrow shows causality. A variable at the tail causes a change to the variable at the head of the arrow. Okay, so there is an arrow and it's always between the tail and the head to show causality, to show cause and effect between two variables or two factors. So that's your number one important component when it comes to CLD. Now, number two is, and you could see there is an arrow with a positive sign there, or a symbol. So this, if you see that positive sign, a plus sign near the arrowhead, this indicates that the variable at the tail of the arrow, and so from your left side of the arrow, and the variable at the other at the right hand side of the arrow change in the same direction. So they indicate a change in causality of in the same direction. So if your tail increases, the head increases. If the tail decreases, the head decreases. Okay? Now, number three, with a minus sign, is the opposite. So the minus sign here near the arrowhead indicates that the variable at the tail of the arrow and the variable at the head of the arrow change in the opposite direction. Okay? If the tail increases, the head decreases. If the tail decreases, the head increases. So you've got whenever you see a plus sign, or you can include a plus sign when the causality is moving to the same direction, whereas your minus, or you can include a minus sign when causality is moving the opposite direction. So one indicates same direction, the other one opposite direction. So this is your third important thing that you need to keep in mind when it comes to causal loop diagrams. Now, let me explain the last two, which is number 4 and 5. Important things that you need to also keep in mind when you start drawing these causal loop diagrams. So if you see a letter R in the middle of a loop, this indicates that this shows that the loop is reinforcing a behavior in the same direction, causing either a systematic growth or a decline. It is a behavior that is moving away from equilibrium points. Okay? So that's your R. Whenever you see an R sign in the middle of a causal loop diagram, or you can put the R sign to indicate that the loop is reinforcing a behavior in the same direction, causing a systemic either decline or a growth in the causality, in the behavior. Now, finally, when you see a B sign or a B letter in the middle of a causal loop, that indicates that the loop is balancing and moves the system in the direction towards equilibrium or a fluctuation around equilibrium points. Okay, so keep that in mind. You can include R in the middle of a loop, or if you see R in the middle of the loop, this indicates that we have a reinforcing behavior in the same direction. So there is a growth or there is a decline. That is a systematic growth or decline. And if you see a B letter in the middle of the loop, that indicates a balancing. We are balancing behavior. And that moves the system in the direction towards equilibrium. Okay. Now, let's take an example. Okay, so Haraldson gave actually several examples, one related to water, which is straightforward and has been used before by other system thinkers. He used also another really good example, simple example to grasp, which is relationship between births and population and death, to make it easier for you to grasp all these 5 concepts when you are drawing a causal loop diagram. I will be using here one of the other examples that he used, which is an interesting one. And it is to explain the causal loop diagram concept in practice. So this example by Haraldson, which he used in the reports, is about urbanization urbanization and job opportunities. So Harlson says first of all, you can start with a question or a problem, the problem that you're trying to deal with. In this case, he suggested a problem, as an example, which you want to understand. So you want to understand what happens to job opportunities when people move to a town, okay? So you want to know what happens to jobs and job opportunities if people move into a town, a random town, okay? Which is, in reality, it happens all the time. So what Harlson says is that what you do is you start with your variables, okay? So you've got your stakeholders, which I talked about in a previous video. You sort out your variables with different stakeholders. You gather these variables, okay, that are part of that system. And then you start constructing a diagram after you've consulted your stakeholders. So now you should start reading the story out of a loop. You start constructing a causal loop diagram. So here I've listed these in the slide here. So what you start with is, first of all, you could see your variables here. You've got the industry, you've got service demand, people moving to town, service job opportunities, and industry job opportunities. You've got these variables. So in step one, you place your variables. In step two, you determine the causality, the cause and effect, using the arrows that I just spoke about, from cause to effect. And then in step 4 and 5, you write what Harlson calls the polarity for each link, which is your pluses and your minuses for each link between one variable and the other one. And then in step 6, you write the loop behavior, which is whether it is reinforcing or it is balancing. Okay? So let's talk more about the industry. About this example. So as the industry is placed in town, there are industrial job opportunity created there. So you've got more industry, that means more job opportunities. This drives people to move to town. And when people move to this town, they take the industry job opportunities. So more people, then less job opportunities. This is your first loop that you could see here. The second loop then comes from a secondary effect of people moving to this town. It creates demand for service, which in turn, as a result, creates an opportunity for jobs and services to service the industry workers now themselves. Again, that places more demand. And in this case, more demand causes more opportunities. Now, when the service job opportunities increases, it feedbacks back to people moving to this town. And this causes more people to flood to that town. They start to come. So people moving to town also take jobs in the service sector. And this reduces the number of service job opportunities that are available in that town. So because of that, we have now 3 loops here that you could see on the slide that affect people moving to town. So the variable industry here, keep that in mind, is not affected by any other variable in the loop. And as a result, we consider it an external variable or an external factor in the system behavior. And it is an external factor because it was not part of the question that we're trying to answer, which is what happens to job opportunities when people move to town. So this is an example, a really realistic example that Harlson gave under page 25 to explain how you can move on from your variables that you picked up with stakeholders. You've got them randomly put on a piece of paper, and then you start drawing the causal loop diagrams and feedbacks because of that, in order to answer your question about what happens to job opportunities when people move to town. Okay. Now, always remember there are certain things that are really useful to remember that Haraldson listed under several pages. Once you indicated your polarities, that is the positives and negatives, the pluses, and minus signs on the causality links, they always stay the same. It is also important to use the right wording when you explain causal loop diagrams. Also, once it is set, you can change the polarity, that is the plus and minus signs. It should correctly read in either direction. And also, all systems have some kind of delay, ranging from seconds to decades to millions of years. So these are the things that Haraldson listed. Now, something that I need to talk about, which is delays, and it is important to talk about this because it is you'll come across that concept, and I'll explain more about delays, system delays. Everybody, you are familiar with waiting time. So standing in line at the bank, keeping patient while the car is getting warm in the winter time. So all of these things are delays. All systems have some kind of delay, which can range from, as I just mentioned, seconds to millions of years. These delays are what cause systems to fluctuate. And a delay is when an action between two parts in a system is much slower than the rest of the system. And a good example is when we take that Haraldson used, and it's actually a useful example, when you take a shower. Okay, everybody knows that it takes some seconds for the hot water to become warm. And since it is cold in the room, we want the water to become warm as quickly as possible. So we can turn the shower tap wide open. But it takes some time for the water to become warm, since your pipes that you're using in the house that are there are long, and the water has to travel a long distance before it reaches the shower head. So when the actual hot water arrives, it is so hot that you are forced to turn it down and increase the cold water tap, which results in a too cold water now. So we end up in this seesaw situation where we continue to adjust the shower head until the water is just right for taking a shower. So I included here a CLD, or a causal loop diagram, to show that Haraldson used under page 30 of that water temperature and how it looks like. So Haraldson says that when drawing a delay, you have to keep in mind that this is a conceptual exercise to understand how the delay is affecting the system. So in the shower case, the delay is only a minute's term, and we draw it between the shower tap settings and the water temperature, because it is in that link that the water make the journey until it reaches the shower tap. So delays are hard to predict within a system. Most of the time, we do not know how long that delay period is for. So what we tend to use is really trial and error to assess the delay time. And this is similar when we are taking using the example of a shower. We're really testing it. We keep adjusting until we reach a certain point. Usually one rule of thumb can be applied, which Harder suggests, and that is the longer the time delay, the larger the oscillation and its effect on the system. And this poses difficulties when we are analyzing a problem, because we may not discover the feedbacks that have long delays. And our mission here is really to work in some way like a detective, finding out which factors might involve long delayed feedbacks. And decision can often create instability and also oscillations within that system that you are examining. And this is not easily felt. So keep that in mind. So we might push some variable very hard without getting any instant results. But the harder we push the system, the harder the system pushes back. And this is important to understand when you are considering, long-term conditions, not just, short-term, that we can work out very easily. So always keep that in mind. So I thought that would be useful to explain delays when it comes to causal loop diagrams. And I hope this video has given you some sort of an introduction, a flavor of what causal loop diagrams are, at which point do you start drawing them, what are the basics, the 5 main parts that I explained when it comes to drawing causal loop diagrams, to kickstart and give you some information, and hopefully you can dig deeper, whether through the report or other sources as well.